Hello everyone, welcome to Chip Confessions. In this session, we are going to see the reasons for randomization failure. In the previous videos, we saw constraint mode, rand mode, and the usage of asset and all. In this session, we are going to see why randomization can fail and what can be the reasons behind it. For that, let us take a example code snippet. Let us take a class first. Let the name of the class be my class semicolon and ending with end class. Now we shall declare variable rand bit 7 down to 0. Let the name of the variable be a, and then rand bit 7 down to 0. Let the name of the variable be b. Let us write constraint c1 and let this be for variable a, and let a be greater than 50. Just like that, randomly we are writing this constraint. And next we are taking constraint c2. Let this be for variable b, and let us say b should be less than 100. This is the constraint for variable b. Randomly we have taken these two constraints. Now what we have to do is we have to declare a module with the name tb and ending with end module. We shall declare the object of type my class. So my class, let the name of the object be MC, and let us give a constructor here itself. We can declare the object with constructor inside the initial block also, or we can directly assign the constructor here itself, means outside the initial block. Now we shall take the initial block begin and end. Now what we have to do is object dot randomize, and let us display the randomized result. A is equal to %d, comma p is equal to %d mc dot a and mc dot b. Whenever we are accessing the variables outside the class, we have to use the object, otherwise it will give an error. Let us run the code and see whether this both constraint and randomization are working or not, and then we can see the causes for the failure. We can induce those causes and we shall see the failure. We are running the code and we shall see the output now. So yes, we are getting a as 211, means a should be greater than 50, some random value greater than 50 a is getting, and b is 62, so b is less than 100. These two values both a and b are getting. So what we can say here is both constraint is working and randomization is also working fine. Now we have to see the conditions or the cases when randomization can fail. First is the conflicting constraints. Here we have written a is greater than 50. If we write another constraint telling a is greater than, a should be less than 50. Now let us just see how this is going to behave. We are seeing randomization failed. The condition of randomized call cannot be satisfied because the following condition cannot be met, that is a less than 50 and a greater than 50 both cannot happen, which is not possible. So then randomization is getting failed. The first reason is conflict among the constraint, means whenever we are giving some condition inside the constraint, that those conditions should be should complement each other, means both should be satisfying, it should not be contradictory. Let us see another condition where randomization can fail. What we shall do is, let us remove this rand keyword and we shall see how this is going to behave. So randomization failed. The condition of randomized call cannot be satisfied. Following cannot be met. Same thing. we are applying the constraint on variable A, and we are randomizing variable A, but we have not declared variable A as rand. So this, whenever we are doing randomization, rand keyword is must. So this is the second condition where randomization can fail. First condition is whenever there is a conflict among the constraint, then also randomization can fail. And another condition is whenever we declare a variable on which the randomization is applied, on that if we do not use rand keyword while declaring the variable, then also randomization can fail. Then we shall see another condition where we use inline constraints. So let us see some basic things about this inline constraint. Basically, we divide constraint into two types. One is in-class constraint and inline constraints. These in-class constraints are nothing but whatever the constraints we are declaring inside the class. That is what in-class constraint is. Means this in-class constraint will be present inside the class, where this inline constraint is not declared inside the class, but it is declared whenever we are randomizing. Means on the randomize call, if we are declaring any constraint, that is called as inline constraint. That is, if we are randomizing a variable, let us say object dot randomize with some condition enclosed between two flower brackets. If we give any condition here, this will become the inline constraint. So what is the syntax for inline constraint is object name dot randomize call. We have to use the with keyword, which is very important for the inline constraint, and then after using the with keyword, we have to give the condition enclosed between two flower brackets. That is what inline constraint is. So how can randomization fail if we use an inline constraint? That can be the doubt. The thing is, if this inline constraint is complementing with whatever the constraint we have declared inside the class, that is, if inline and in class both are complementing each other or both are satisfying each other, at that time randomization cannot fail. But in some situations what can happen is inside the class some constraint we are giving, and while on the call of randomization we are declaring some other constraint or we are imposing some other constraint. At that time, if the condition whatever we have given while on the call of randomization is not satisfying the in-class constraint, or if it is bypassing or overriding the in-class constraint by not satisfying the condition, at that time the randomization can fail. We shall see how it works in the code. Means both in-class or inline constraint should be complementing to each other and should not be contradictory. That we shall see now. So we have got a randomized call here, and what we are doing is we are declaring a inline constraint with the help of with keyword. Means the object name dot randomize call with, we have to give some condition now inside the flower bracket. That is, let us give a should be greater than 100. This is the, we have to end the condition with a semicolon. So what we have to do is, like, we have given a constraint inside the class as a greater than 50. On the same variable a, we are giving another constraint on the call of randomization as a is greater than 100. So let us see whether this is working or not. So we are getting EAS 167. So randomization is not failed because this A is greater than 50, this A is greater than 100. So anything greater than 50 can be greater than 100 also. So these two conditions are getting satisfied, or both together are complement to each other. So we are not seeing any randomization failure here. What we have to keep in mind is this inline constraint always overrides the in-class constraint. Means if you are giving an in-class constraint and after that if you are giving an inline constraint, the thing is whatever we give in the inline constraint, that will override or that will bypass whatever we have given in the in-class constraint. So whenever we are giving an inline constraint, we have to keep it in mind that it should be complemented with the in-class constraint and it should not be contradictory. We shall see the failure condition now. What we have given here, A should be greater than 50 in the in-class constraint. In the inline constraint, what we can see is A should be less than 20. So both are contradictory to each other. Means there we have given A is greater than 50 and here A is less than 20. Like that we have given some condition. So both are contradictory to each other and we shall see now how it behaves. We can see randomization failed, condition randomized calls cannot be satisfied. This is what is happening because these two conditions are contradictory. Now if we give A should be less than 10 here, so A can be less than 10, A can be less than 20 also. Let us see how this behaves. So we are getting the value. Means what we have to keep it in mind is whenever we are using an inline constraint, it should not be contradictory to in-class constraint. Okay, some situations come up. At that time we cannot check or we cannot see what in-class constraint holds or inline constraint holds, or we cannot check with the inline constraint. We have to use the same, let us use the same condition. A should be less than 20, but here what we do is same condition we will retain, A should be greater than 50. In the previous run what we saw was this was creating a compile error, or means randomization failure error. We shall see again what it is generating. So we can see randomization failed. We are seeing that. Now how to avoid this failure, even though if we cannot check whether these two, that is in-class and inline constraints, are complementing each other. That can be done by using a keyword called soft. This soft keyword can be used inside the in-class constraint or inside the class, so that this inline constraint can prevail the in-class constraint. Means anyhow this is overriding, but while overriding, even though these two conditions are contradictory, this inline constraint will override the in-class constraint completely, so that this will not come into picture. That is with the help of soft constraint or the soft keyword. Let us run the code and see now. So we are able to see the value of A and B. So randomization is happening now. Initially without the use of soft keyword we were seeing randomization failure, but now with the help of soft keyword we can see the randomization is not getting failed. This is how we can avoid the constraint conflict in between in-class and inline constraints. We saw how randomization can fail, means the causes for randomization failure in this video. One is if we do not use rand keyword on which the randomization is happening, on which variable the randomization is happening. Second is constraint conflict in between the in-class constraint itself, and third one is constraint conflict that can happen in between both in-class or inline constraint. So this is all for this session. In the next video we shall see how to solve some constraint questions, means interview level constraint questions. Thank you so much. Keep coding. Stay tuned for the next video. Please like, share the video and hit the subscribe button so that we can see much more such kind of videos. Thank you for watching. Thank you.